This conference will now be recorded.
Yeah. So the question is that what are the dependencies we have added? These dependencies will be added with admin or a developer. These dependencies will be added with the developer only. So developer will be knowing that what are the dependencies is required. Suppose if any third party libraries apart from whatever is defined by uh, whatever is required, let's say Spark SQL, machine learning, and others, XML, CSV, Databricks. These are all we require. But let's assume that there is a third-party library which is something called Databricks Excel sheet or XML processing. One library is required. Okay. Normally, what will happen in few companies, you cannot directly connect to the Maven. Okay, so it will not allow because it's a security, all this stuff. So what they will do, they will allow you to connect to one of their server. There is something called some Nexus server will be there. So you will connect to that Nexus server. Okay, so whatever the libraries are available in the Nexus server, you will download from there. Okay, so if any of the library is not available in the Nexus server, you will raise a request. Okay, you'll tell to your lead or you'll tell to your admin saying that I need this library for this. So if that library is allowed to use in your project, well, then what they will do, they will bring that into the Nexus server. Then from the Nexus server you will able to download it. Okay, but all this putting the dependencies and everything is developers responsibility. Clear, is up?
Yeah, Ravi, thanks.
Okay. Okay, so 1 second, let me connect my pen pad, then I'll show. Okay, let me share my screen today. So please let me know once you are able to see my screen.
It's visible, Ravi.
Okay. Okay. So yesterday we have written a simple program, correct? So as we know that the Spark architecture is master slave architecture. As we know that the Spark architecture is master slave architecture. So let me draw that. It's actually I think we already discussed about it. So but anyway, I want to explain since we have written a program. I want to explain once again in the okay. Let's look at it. Yeah. Okay. So the Spark architecture is Spark, Spark architecture is you will be having a master. You will be having a master, and you will be having some workers. Slave. It's also master slave architecture only, and you will be having cluster manager. You will be having a cluster manager. Okay. Let me do this. Okay. So this is a master. This master, you will be having something called driver. Driver is in the master mission. Actually, the driver will be there. Driver, who drives your application. Driver is nothing but who drive your application. The driver program normally will call your Spark session or your Spark context. This is your Spark context. Your cluster manager is can be, as we discussed, like there are three type of cluster managers: standalone, yarn, mesos. Standalone is by default. Yarn or mesos we need to specify. Cluster manager. And these are worker nodes. These worker nodes will have what these worker nodes will have: executors. Like how we'll call a driver, we will call executors. Okay, executors are nothing but another process, a child JVM process. Okay, these guys will have the respective tasks. I'll say task T1, I'll say task T2. Let's assume that this executor has three tasks, and it will also will have some memory for caching. Cache. Okay, now the connections will be like this. Okay, and these guys will just with the driver program as well. Okay, this is the Spark architecture. Okay, so in yesterday's program, if you see that we have first what we have done, we have created our Spark session, Spark context. Yes or no? What we did in the in the yesterday's program, first we created, first we created
Part session.
Spark session. From there, we'll create a Spark context. So that's your driver program. That is your driver program. You can say that is our driver program. Once the driver program is initialized, created, what it does, it is actually goes through all your program. Okay, that is a part of your flow. But anyway, let me explain the roles and responsibilities of this guys. Okay, so this driver program, right? It will run on the master node. Okay, so this driver program will run or start from the main method. In the main method only we will write this driver program. No, so there only we will be creating our driver program. Yes or no? That main method only we will be creating a driver program. Correct? So once we create it, once we create it, wherever we create a Spark context, that's we'll call as a driver program. What it does, this driver program is responsible for task scheduling, DAG. DAG, we'll talk about this terminology. Just make a note of it. DAG, 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 direct acyclic graph. keep it here. Tag. So this is actually, it actually contains internally um, DAG scheduling and task scheduling. Okay, it has one more. There is something called block manager. There is something called block manager, and so on. There are a set of functionalities will be there for your driver program. These are, will call as a different components. So each component have a respective functionality. Okay, so it actually runs in the driver program to schedule the job and execute and negotiate with the resources. Negotiated with the resources. To whom, with whom it will negotiate the resources? With the cluster manager. It will talk to the cluster manager, and cluster manager will has, let's take in case of yarn. Let's take in case of yarn. I'll just make a note here. Let's assume that it is a yarn. Yarn actually is a different components: resource manager, node manager, application master, application manager, scheduler. There are different kind of components out there in yarn, right? So your driver program, what it does, it negotiate the resources from the cluster manager. Once the resources has been allocated, your driver program will register, or your worker nodes will register with the driver program, and your driver program will submit the job. Your driver program will submit the tasks. Your driver programs schedules the task. Your driver program schedules the task. Okay. So yesterday what we did, let's assume that yesterday I have done this operation. Okay. I have a RDD1 I created. It means I read the data. That is RDD1. After that, I applied some map transformation. It got RDD2. After that, I did some more transformation. That gives RDD3. After that, I did some more transformation. It gave me RDD4. We'll see in detail what is RDD. For now, RDD is nothing but collection of distributed collection of data, and RDD contains the partitions, and the data will be processed based on the RDDs. Okay, how many partitions are there? Those many tasks will run. The partitions are not nothing but your input splits. Okay. Okay, so you see here you are getting this graph.
Ravi, we cannot hear you. Hello.
Ravi, we can't hear you.
Hello?
Hello? Hello? Am I audible?
Now you're out.
Yes, Ravi.
It, it looks my network is gone. Okay, 1 second, let me check what happened to this. Don't know what happened. It looks as my network is gone, but I have connected through mobile. Let's see. Okay, so I don't know where I lost. I was talking about we created RDD1 by reading the data and apply the transformation 1, transformation 2, and so on. So then we call an action. Till here I covered last time. I mean, before I disconnect. So once this plan comes, okay. So my driver program, what it does, it will the driver program translate this this translate this plan, this RDD's execution graph. What it does, these RDD1, RDD2, RDD3, this is how it has to be run, right? Translate this RDDs into executable graph. That executable graph is nothing but a DAG. These RDDs will be translated into a execution graph or executable graph, that is called DAG. And once this DAG is ready, your driver program, once this DAG is ready, this DAG will be split into stages. Split into stages. Split into stages. How it will split into stages? You guys remember I have told you there are two type of transformations: narrow transformations, wider transformation. Do you guys remember that? So this DAG will be split into stages, stage 1, stage 2, like that, or stage 3, depends on the type of transformation we applied. So once this is divided into stages, each stage is nothing but set of tasks. Each stage is nothing but set of tasks. Okay, so this stage is again divided into tasks. Try to remember, guys, this is how the responsibility of the your what I can say, uh, driver program. People will ask in interview, what is a driver program? What is the executor? Okay, so to answer that question, I'm covering here. So if you know this one, it's easy to answer those questions, and you can easily understand when I'm explaining the other transformation and other programs. Is there any doubt till so far? Any doubt so far?
Ravi, here I have a question.
Please.
So here the driver program is responsible for converting RTTs into DAG, and then the DAG will be converted into stages and then execute and then tasks,
Stages will be
right?
tasks. Correct. Each stage is
So
nothing but set of tasks.
yeah, so everything is taken care by driver program. Then what is the purpose of cluster manage here?
I'll come to that. So it still is not yet come to the cluster manager, is still not yet come to the executor. So it is a plan. It is preparing the plan, right? Do you see this? It is just a preparing a plan. It is not executed, right? It is not, execution is not yet started. Execution is not yet started. It's just preparing the plan. Okay. So RDD1, RDD2, RDD3, RDD4, and all these are the transformation they applied, and these are the stages, because your execution will go based on the stages and tasks. Okay, still the process is not yet completed. Once your driver program convert this plan, and it stores this metadata information. This metadata info, whatever I have explained here, right? So for it's creating a DAG and splitting into stages and tasks, right? That information it will store. What that information, which is about RDDs and their partitions. Okay, you got it?
Yeah, yeah, Ravi.
Ravi, it's a bit confusing. Can you repeat it, please?
Okay, so you have your program like this. You can see that right hand side RDD1, RDD2, RDD3, and so on. Okay, that is a sequence of operations which needs to be performed. Okay,
Yeah.
now, so once this sequence of operations are you have written, your driver program, what it does, it will translate that sequence of operations into one executable plan. That executable plan is nothing but DAG. Is this clear?
Yes.
That executable plan will split into multiple stages.
Mhm.
Stage 1, stage 2, stage 3. How these stages will be divided? Based on the type of transformations. Based on the type of transformations. Narrow transformations, wider transformations. Narrow transformations will go into one stage, wider transformations will go into one stage. So we will discuss about the narrow transformations and wider transformations. You just keep that information. You just keep that terminologies. I'll explain you.
Okay.
Okay. Now, once the stages are created, your driver program, what it does, it stores the information like metadata information, what is the RTD and what is their partitions. Once that is done, your driver program already converted into stages and tasks, right? The small tasks. So each partition will be one task. Okay. So these tasks actually will execute by executors. What are the tasks I have defined here, right? These tasks will execute in the executors. But who will launch executors? Who will launch these executors? For that, your driver program will go and talk to the cluster manager. Saying that, hey, this is the plan I have. This is the data I need to process. Get me the missions. Get me the missions. Once your your cluster manager understands the requirement, and brings the machines based on the data locality. You guys remember data locality? Wherever the data is there, it will try to bring those machines. Nearest data, wherever the data is there, it will try to assign some machines based on the request. Ba there are two ways of allocating the resources. One is dynamic, one is static. Dynamic allocation, static allocation. We will talk about this also. Try to remember this terminology. Dynamic allocation, static allocation. Okay, static means we'll specify that no, I want these many executors, I want these many cores, I want these many driver memory, I want this much executors memory. Like that, we will specify that. That's called static. We will specify that how much resources we want. Dynamic means by the default configurations will be there. It will allocate based on the task and based on the what is the task and how much data is required. It will allocate its own. Okay, we'll discuss in detail about it. Now the cluster manager, what it does, what is the responsibility of the cluster manager? It will talk to the resource manager and allocate the resources. The resources are nothing but your worker nodes only. The resources are nothing but your worker nodes only. What it does, it acquires the resources. After acquiring the resources, it will allocate to the Spark job. Okay. Then once it's acquired the resources, these resources will register with the driver program. That's all they have this flow. You see, they register with the driver program. Why they have to register? Because when they are running any application, your driver program will be monitoring it. When they are running any task or something, your driver program will be monitoring it. In case of any failure happen, in case of anything happen, it has a metadata information. That's called, we'll call as a lineage graph. DAG will be converted into physical plan. There is something called logical plan, which is called lineage graph. We'll talk about that also. The lineage graph, with the help of the lineage graph, it will again reconstruct that failed RDDs. That is called resilient, fault tolerant. Resilient means fault tolerant. Okay, so once these worker nodes are registered with the driver program, once this cluster manager allocated their worker nodes and this worker nodes registered the driver program, the driver program will submit the job. Now, when submit the job, each and every worker node has some executors, right? Based on the executor is nothing but a JVM process. One worker node can have multiple JVM process based on its capacity. One worker node can have multiple executors. Try to remember this is most important. Executor is not a physical component. It's a logical processing component in physical box. So one physical box, which is a worker node or data node, can contain multiple executors, multiple logical processes based on its capacity, based on size of the RAM, based on size of the cores. Okay, are you guys able to follow? What is the executor's responsibility? The executor's responsibility is executing the tasks. Very simple. Okay, what is this executor? As I said, it is a processor, JVM process. Okay, so every Spark application will have some executors, or executor has to be there, and those executors are nothing but some processes. Each process contains their respective tasks, right? One process will contain the parallel tasks. Yes or no, guys? Any doubts so far? These executors will be keep on running until your job is completed. Until your job is completed. Okay. All suppose I have launched 10 executors. All these 10 executors will be keep on running until the job is completed. Some executors may complete their job, still they will be waiting for other executors to complete. Okay. Are you guys getting? So we need to understand this architecture. So then only we can understand the Spark. Any doubts so far? If you guys have any doubts, please don't hesitate to ask. Is it are you guys able to follow? Okay. If no doubts, I think I'm assuming everyone is following. I'm repeating again. Executors are processors who has the tasks. Once the job is submitted, the task like a map task, the map operation has to apply on each and every data piece, right? That piece, that RDD will have some partitions, right? I think I have shown this earlier. So this is if you assume this is your RDD, this RDD will be divided into partitions, partition 1, partition 2, partition 3, and so on. So this piece is nothing but piece of data, right? This piece of data will be processed by task 1. This piece of data will be there, right? This piece of data will be processed by task 2. Okay. So each and every data will be divided into partitions. Based on those partitions, the tasks will be running. One partition, one task. So similarly, suppose if I have some amount of data here, so that will be processed by this executor. Some amount of data here, this will be processed. Some amount of data here, it will be processed. It's called parallel processing. The main
Ravi,
yeah.
here I have a question. So here, the number of partitions are depends on the course, right? So in
Hmm,
this we do have 8 partitions.
hmm,
So we have 8 splits. So 8
hmm,
tasks.
hmm,
So at the end, if we do print or something,
hmm,
so like each task is performing one partition. Okay, assume
hmm,
we have 8 partitions, then 8 tasks. So
hmm.
at the end, again, how it is cumulating everything and giving the output in a single variable?
That's where we are writing our collect. Collect is actually collects the data output from all these machines, right? Your collect, your collect, your save, or whatever you write, right? See,
That is action, right? Uh,
that's action. The
Yeah, each
action.
individual task is performing its job and it's done, right? So
Hmm,
where exactly, like the I got 8 tasks, for 8 tasks I got 8 outputs. Where
hmm.
at what point of it's combining everything and giving one output? That is my question.
That's at action. At the action level, it will happen. If you don't have action, there won't be data process. You are telling that the task one is executing. So to task one to execute, that action should be called. If the action is there, then only the RDD1, RDD2, RDD3, RDD4, this plan will be executed. If there is no action, there is no data load. Okay, let me put it in this way. Okay, let me write it here.
So,
Hold on.
Ravi,
Hmm.
one thing. Action
Yeah.
will be performed at the driver node, or it will be happening at the data node. It should be happening at the driver node, right?
No. Why it should happen at the driver node?
Because it
Action
has
is
to combine all the data from all the worker nodes.
that collected data will go to the driver. The collected data will go to the driver.
Okay.
Okay. Not every action. Not every action. And also, I'll show you that one more example. Okay. Let's say RDD1, RDD2, RDD3.
Ravi, sorry to interrupt. Just take our example and explain so that we will understand in a better way.
Yeah, same our example only. No, this is where we read the data here, right?
Okay.
Data we read using c dot parallelize. Then what we
Yeah, yeah.
did, we applied the map transformation, multiply by 10 or something. RDD2 we get. Then let's say after multiplying we did filter, let's assume that. Okay, after filter we did distinct. These are the operations. Now I call an action. If you don't call an action, these operations will not happen. You will not get the data. You will not get the data until you perform an action. The transformations will not be executed, only plan will be there. That is called lazy evaluation. You guys heard about the lazy evaluation? Until you call an action, the data will not be loaded, the operations will not be performed, but plan will be created. Plan will be there. Oh, RDD1, next RDD2, next RDD3, next RDD4. That's it. There won't be any action happens. There won't be any data load will happen. So when you call an action, that depends what type of action you are calling. What type of action you are calling. Based on that, first the action, let's say the action has to perform on the RDD4. Hey, I need to perform this operation on you. Then it says, hey, I don't have any data, I depend on the parent. Then this RDD3 look for this, and RDD3 says, I don't have a data, I depend on the RDD2. Then it will go here. This guy also says something, I don't have a data. Once the data is available, then only I do the filter. I don't have the data. Then this is called child. RDD4 is depend on the RDD3. RDD3 is depend on the RDD2. RDD2 is depend on the RDD1. RDD2 is dependent on the RDD1. The RDD1 actually loads the data. This will call as a base RDD. We'll call base RDD or Hadoop RDD. Once the data is loaded, then map transformation will happen. The result of that, it will go to RDD2. After that result, RDD2 comes. We did filter. The result of the filter will go to RDD3. After RDD3, we did a distinct. The result of this will go to RDD4. Then this result we did action, right? The collect or save or whatever it is. Based on that, it either will write into file or it will display into console or it will write into the table, whatever the operation you perform. You understand this? This is called lazy evaluation. Until you call an action, there won't be any data load will happen. Is this clear? Is this
Ravi,
clear
here
or not?
each RDD will be going to one worker, no?
Sorry?
Each RDD will be going to one worker, no?
It is not each RDD. One RDD will be distributed across the multiple nodes. RDD1 will be there in the 3 nodes. RDD2 will also will be in 3 nodes. I mean, I'm just taking an example of 3 nodes. RDD3 also will be there in the 3 nodes. RDD4 also will be in 3 nodes. Okay, it is a distributed data set, right? It's a distributed across the multiple machines. So the RDD1 is a full data. The RDD1 is nothing but your full data. Let's take an example. I have 1 GB data. When I read this data, one RDD1 will come. This 1 GB data will be there in one machine. However, Hadoop works, however MapReduce works, is whole 1 GB data will be there in one machine, or it is distributed across the multiple machines based on the block size.
Distributed across the cluster.
So distributed data, right? So whatever the data is there, that's what we need to assume. Whatever the data is there in the worker node 1, whatever the data is there, the piece, whatever the piece of the data is there in worker node 2, whatever the data is piece of the data is there in worker node 3, that data will be processed. Let's assume that this 1 GB data, 1 GB data distributed to 3 machines. Let's assume that. It means 8 pieces will come. Normally 8 blocks. 8 blocks will call 8 partitions. Okay, so I'm talking with respect to HDFS. So 8 blocks. 1 GB means 8 blocks. 8 blocks means 8 partitions. Okay, so let's assume that if it goes round robin fashion, so I have a partition 1 here, partition 2 here, partition 3 here. I'm just taking an example. It never happened in the sequence, so randomly it will distribute the data. Okay, and again partition 4 will be here, partition 5, partition 6, partition 7 and 8 will be there in either of first mission. Let's say partition 7 here is, partition 8 is here. Now you tell me, how many tasks will launch in the mission 1? How many tasks will launch in mission 1? Worker node 1.
3 tasks.
Worker node 2, 2 tasks. Worker node 3, 3 tasks. You're understanding what I'm trying to say? So the whole 1 GB data is one partition here. Can I say 1 RDD? This whole is 1 RDD? Yes or no? This is 1 RDD. This RDD divided into partitions. You really need to understand this thing, okay? Otherwise you'll totally confused with how internally to work. Partition 1, let's say this is partition 8, I'll take partition 7, and so on, 2, 3, 4. Now when I apply this is the whole data, guys, the whole data. This is the whole RDD. This is RDD1. This RDD1 is created on top of all these worker nodes, correct? Yes or no? Now
Yes,
when
sir.
I apply the map transformation, map is a task, right? Whatever the operation you perform, like incrementing by 10 or filter, whatever operation you do, so this operation will run on this piece, the same operation will run on this piece, the same operation will run on this piece. This is T1, T2, T3. Same operation will run on this T4, and so on. The same operation will run on the T5, T7, T8. Same operation should apply in the piece of data. Let's say I am incrementing by 10. Each element or each data I'm incrementing by 10. So this increment should happen on the data which is there in this partition, yes or no? The whole data should happen, right? The increment should happen in this partition piece of data also, right? The increment should happen in this data also, right? The increment should happen in this data also, right? Yesterday I shown that yesterday in the with the help of the gloom. You saw that in every partition has some data. Some are the empty partitions are there. Whoever has the data, when I apply the map transformation, the reflected partitions also will have the incremented data or not? Still any confusion?
No, Ravi.
Suma?
Yeah, Ravi, still I have confusion.
I don't know what is your
So,
confusion. So that's what you can clearly help me with your what is your confusion?
yeah,
I'll try to.
you said partition P1 to P8, right?
Hmm.
So these are on different worker nodes and different tasks. So
Hmm.
where exactly it is combining everything and making it to one RDD in the
Uh,
end?
that is a logical, ma. Your RDDs are logical, right?
Okay,
The process is logical. The physical data will be there in the machines. The
okay,
process is logical. They will bring the data into the memory. So all together is nothing but collection of all partitions is nothing but one RDD. It is
okay,
not collecting all of them and putting into one place and then it's not doing. This RDD is nothing but distributed across the multiple machines.
okay.
So now the P1, so okay. Now P1, P2, P3 output, where it will go? Which machine it will go? You guys tell me. It's in memory process. Let's say it all will go in the memory only. So task 1, task 2, task 3's output will go where? Which machine?
It will
Which
be in the
machine?
same machine only.
It will be the
Same
same
machine.
machine in the memory. Yes, machine 1's memory. So task
Alloc-
2 on 5,
It
it will be
will
the
be in the same
worker node.
allocated resources. Yeah, yeah.
Yes. Okay, now I applied, so now the output of this will be there in the memory. Okay, it's a memory, and this output will be there is memory. This output will be there in this memory. Now you applied one more transformation. Let's say you did filter the same, right? The same one kind of RDD will be created. So all this together only will call RDD2. No, all this together will call RDD2. That RDD2 will be here. So in this RDD2 output of the mapper is your RDD2. RDD2, it is RDD2. On this RDD2 you are applying the filter. Yes or no? Are you following, ma Suma?
Yeah, Ravi. Now I got you.
This is partition 1, partition 2, partition 3, partition 7, partition 8. Now when you apply the filter operation, on RDD2 output of the mapper, then again task will perform here. This task will perform here, output of this will go to again the same machine. Based on the type of transformations. I cannot guarantee that always the output will go to the same machine, because these transformations, whatever I'm showing here, there is no data shuffle. Okay, since there is no data shuffle, the data will be there in these machines only, respective machines. If the data shuffle is there, what will happen? Some data will shuffle across the machines. That's called wider transformation. So these are called narrow transformation. If there is no data shuffling, those transformations will call narrow. If there is a data shuffle, those transformations will call wider. Is this point is clear?
Yeah, Ravi.
Ravi, please repeat this last point. Just over to
If
what you said.
there is no data shuffle, if suppose you apply some transformation and there is no data shuffle, those transformations will call narrow transformations. If there is no data shuffle, those transformations will call narrow transformations. If there is a data shuffle, let's say by key operations, when you do the by key operations like a joins, group by, reduce by key, group by key, so that time what will happen? The data will shuffle across the multiple machines. So output of let's say I applied the group by operation, output of the partition, see this is machine 1, right? Output of the partition 1, the key may go here. Output of this partition 2 may go here. So output of this may go here. So when the output is the data is distributing other RDD, I mean other partitions, partition 1 to partition 4, partition 1 to like that. If the data is shuffling, that when you have a data shuffle operation, those are wider transformation. I'll show you them, so don't get worry. I will show them in detail. Okay, now coming back to here. So once the data plan is submitted, the worker nodes will be executing their tasks respectively. In case of any mission failure, your driver program will have that plan already. The metadata information is already there. With the help of that method, guys, if you're not talking, please keep yourself mute. Guys,
ఏంటి
Raghu, could you please keep yourself mute?
4 days
Raghu, one second, let me do that. Okay. Okay, look at here. Okay, in case your driver program stores that information, right? Your driver program stores that information, right? So since that stores that information, the metadata information, in case of any failure happen, with the help of that metadata information, it reconstruct with the help of the DAG or lineage graph, will reconstruct that RDD in case of any failure happen. That's called fault tolerant. We will see in detail how it will reconstruct and all other stuff. Okay, if you guys have any questions so far, please explain me. And also, if the data can fit into the memory, all the transformations output will go into the memory only. That's what I have written here. If the data can fit enough into the memory, if you have enough memory into your machines, the output will go into the memory. Otherwise, some part of the data will write into the disk, some part of the data will write into the memory. There is something called persistence for that. We will discuss that in detail in the later coming sessions. It is too early to discuss about it. Okay, so then these executors are responsible for writing the output into the files, or displaying the console, or writing into table, or here or there. Any questions so far about the architecture and flow? Any questions? Okay, let's move on. Again, I would like to take similar kind of the Spark application flow. Okay, let me take any one of the example. Let's take, yeah, I have one word count program example here. Okay, look at here what I did. My main method, I will explain this anyway, don't worry. I'm just to explain the Spark flow, I need this example. Okay, I have my object, I have a main method. In that I have this is the driver program part. Then I'm creating RDD here by reading the data, by reading the data. Okay, after that I'm applying some flat map on transformation, flat map transformation. It is a flat map transformation. Then I'm applying the map operation. Then I'm applying the reduce by key operation. Then finally, either I'll write into the save as text file, or collect, or whatever that want. Okay, I have done save as text file. That's an action. Save as text file action. So try to remember, guys, your transformations will return RDD. Your transformations will return RDD. Your actions will return value or data. This is the more important. That's the difference between transformations and action. Transformations will return another RDD. Look at here. I read the data on RDD came. Then I applied one transformation. I got on RDD. I applied another transformation. I got another RDD. I applied another transformation. I got another RDD. But I call an action. There won't be anything. It will return the value. Either it will write into the file, it will write into the table, it will write into the, it will display in the console, or whatever it is. It will return the value. That's the difference between. That's the difference between transformations and action. This is the most important interview question. What is the difference between the transformations and actions? What are the transformations? What are the actions? Okay, I'll give you the list of actions and the list of transformations and all. Okay, is this clear? Now when you look at here, this is, if I put this into a diagram, a DAG. So first I read the data. Let me write a new DAG. Read the data. I got one RDD. After that, on top of this, I applied the flat map. I got another RDD. I applied the map on this. I got another RDD. I applied a reduce by key. I got another RDD. Then I applied action called save as file, save as text file. So here actions happen. Here the actions happen. This is a DAG for me. This is the DAG for me. When I submit this operation to the cluster, what will happen? That is called Spark flow. I think you guys can make a note of it, or you can store, you can make a note here or there. Okay. So after developing the code, we will create a jar. Try to remember, guys. After developing a code, we will create a jar file. This jar file we will submit with the help of the Spark submitter. I'll show that. It's a little early to show this, but to explain the Spark flow, I need to talk about it. There is something called Spark submit command. Then with the Spark submit, you will have some more like your class, your jar, your parameters and other stuff will be there. You have something called Spark submit. Okay. Once you does this Spark submit, what will happen? We are going to discuss. Okay. That's called Spark flow. Okay. Tomorrow will directly examples. That's the reason. Today only I'll try to cover the flow. First, very step one. Step one. What will happen here is when you submit the job. Okay, when you submit your job means your application code, the driver program converts your transformations and actions into a graph. This graph. It means driver converts your transformations into DAG. Try to remember, guys. Okay. Step 2. Driver converted DAG. I got the DAG. So internally, the driver program, once this DAG comes, what it does, it also performs some operations, guys, like a pipelining transformations, like one transformation, which transformation has to execute after what transformation, kind of it actually it's pipelines and converts your logical plan. Actually, initially when it reads it, it's a logical plan. So converts your logical plan into physical plan. What is a physical plan? What is a physical plan? I think everyone knows, whoever comes from the SQL background. So it applies the analysis and it applies the it applies the optimization techniques. It applies the analysis and optimization technique, and it will create the physical plan. Your driver applies some operations and converts DAG into physical DAG, or I can say physical plan, into physical execution plan. If anyone making a note, I can read, I can repeat or give the sentences. You can make a note. Okay. Okay. First step. When we submit the Spark job, the driver program converts the code which contains the transformations, guys. Convert the transformations directly. You can write a transformation. Converts the transformations and actions into a DAG. That's the first step. Are you guys making a note? Then
Yes,
only I
sir.
can give the statements. Yeah, okay. If you guys making a notes, then I'll give the statements. Step 2. After converting into DAG, the driver program performs optimization, analysis and optimization. Actually, it is. You can write analysis, optimization, analysis, and converts the DAG into physical execution plan. Physical execution plan with the set of stages. So I'll tell what is the stages. Okay. So that's a step 2. In step 3, so as we discussed earlier, once this plan is ready, the physical plan is ready, the physical plan will be divided into small executable parts or small executable units, that is called tasks. The physical execution plan will be convert into small executable units, that's called tasks, under each stage. Okay, so now what happened? We created the DAG, applied our optimization, we got the physical plan. This physical plan has been splitted into small task units, and all these bundled task units, we will submit the Spark. After that, driver will send the plan to Spark cluster. Before sending it, actually, so next step will be, are you guys following? Anywhere lost? Next step. Here, the driver program will talk to the cluster manager, and negotiate the resources, and ask for the resources. So what the cluster manager will do? The cluster manager will launch executors on identified worker nodes behalf of driver. Actually, the process goes behalf of driver only, no? Your cluster manager. Once this worker nodes and drivers has been, sorry?
Ravi, can you repeat the last point? Cluster manager launch executor.
Yeah, cluster manager launch executors. Once the worker nodes are available, actually these executors, your cluster manager launches the executors, right, on the worker nodes. Once this worker nodes are available, the tasks will be submitted. Okay, so to repeat the last statement, okay, let me put in this way. Forget the statement what I have to. The cluster manager launches the executors on worker nodes behalf of driver. This is what I have given last statement. The cluster manager launches the executors on worker nodes on behalf of driver program. Venkat, is it clear?
Yes, Ravi, thank you.
Okay, then I lost the step. Okay, once this worker nodes and everything is ready, now the driver program will send, okay, tasks to the cluster, I mean tasks to the, what I can say, tasks. Okay, let me put in this way. The driver program will send tasks to the cluster manager based on the data locality or data placement. Now it will send the tasks into the to the cluster manager based on the data placements, because worker node 1 will have some data. Wherever the data is there, worker node will have some data locality. So what these executors or worker nodes will happen, they will register with the driver program. The next step is the worker nodes or the executors register register with the driver program. So executors will register with the driver program. So the driver program will have a control or whatever holistic view or whatever you call control of or a holistic view of all the executors, because it will be knowing which work executor is doing what, which executor is doing what. Then once the registration is completed, once the registration is completed, once this registration is completed, what will happen here? The executors will start work on it. The executors will start work on their executors. I mean, they'll start the tasks. So whatever the operations you have performed, like a flat map or whatever the operations you started, right, those will be executed. So while it is running, right, your driver program will be monitoring these executors. Driver program will be monitoring the executors while application is running. The driver program will be monitoring while this application is running. So in case of any failure happen, you can write in next step. In case of any failure happen, the driver program will schedule a failed tasks based on the data locality or based on the data placement. Suppose the data is there in other node, it will bring that node and it will start tasks in that. So wherever the data placement, wherever the data is there, based on the data placement, so it will actually so there are two cases. One is completely execute is failed. So there are some cases only task is failed. If the task is failed, anyway the same executor, another task will be launched and process it. So when the complete execution is completed, so normally the main method will be completed, right? So when the execution is completed, let me show you here. When this complete execution, not this one, when the execution is completed, so then your Spark application called stop. There is something called here, actually at the end it will call as a stop method. So you really no need to write explicitly. There is something called stop method. You can see here there is something called stop method. So it will call the stop method. So to once the execution is completed successfully, we really no need to call explicitly. It internally it will get called stop, and that what I can say, and then everything will be terminated. All these executors and everything will be terminated. These executors are not permanent, no, for the job. So these executors can be assigned to another task later, right? So they all, once it is identified and connected to this application driver program, once the task is completed, so it's not required for this application, they will be terminated and releases the resources. Okay, so this is how the process happens from the beginning to end. Any questions? Any questions? So that is about today. So if you guys have any questions, please ask me, else we can connect tomorrow and we will see in detail.
Ravi,
Yeah,
here we are creating Spark context object. We are specifying master of local, right? What is it?
I'll explain that in the next session, Ma. It's a little early to explain. So yesterday also I have told that master of local means this, anyway this application is running on the local. It's not yarn, it is not mesos, it is not some different cluster, it is running on the local mode. Sudo mode will call same machine it is running, right? In that machine, how many resources it required, how many cores. Actually, the machine capacities will be defined by the number of processors and number of cores. So suppose your machine has a i7, 8 cores will be there. Suppose your machine is i10, bigger, more cores will be there. So local means you take from the local machine. The meaning of it is wherever you're running, right? Wherever you're running, take from there how many cores are available, take all the cores. Star means those many. If you can give 2, you can give 4, you can give 3, you can give like that. You can give that number. Okay, ma?
Okay.
We'll discuss in detail about it. Yeah. Any other questions?
Ravi, can
Ravi,
you architecture also?
Yeah, go ahead, Varsha. You were asking something.
yeah, Ravi. I was having questions related to HBase. Can I ask it now or like later?
HBase one will take later, ma. Even
Okay.
actually, I need to get into another meeting.
Okay. Okay.
I have this one.
Okay, thank you.
Yeah.
Thank you, Ravi.
Have you created a new drive for this?
Thank you, guys.